Okay, let's start with the Nano. I have an analog input from the TMP36 wired to analog 0. I have the 5-volt ran to the positive ground, and I have the ground ran to the negative there. This is the HC12 transceiver. It's a 433 megahertz transceiver. The input basically you talk to the TX and RX pins, and it's a serial communications. I have it configured for 9600 baud, which is the same that I have set up in the Arduino code. What are the caveats you need to know about the HC12? Basically, there's a set pin, and if you're wanting to configure the HC12, be it the power, the channel that it's talking on, or the data rate, you need to ground the set pin. And also, if you're trying to transmit, you need to unground the set pin. That will throw you for a loop, and the manual's pretty good on it. So right now I have it configured for channel 0, and I have the power turned down. What else can I say about it? I'll come back to that. So there's the TMP36. It's like TO92 package, I think that's what you call that. It's getting a 5-volt supply. Not super impressed. I mean, it works decent, but I've seen it be off. Maybe I was just having noise, but I had it be off maybe like 5 degrees Fahrenheit. So a little more impressive is the DHT11. It's a humidity sensor, which also has a built-in temperature sensor as well. So you supply it 5 volts, and then its output is not analog like the TMP36. Its output is a digital output. It's sending packets. I think it's a packet of 40 bits, and the library, the DHT library in the Nano, is deciphering those packets and pulling out the temperature and humidity percentage. Lastly, I have this out of the system. Let's pull this up. So when I'm not using the Arduino to power it, I had issues because this HC12 pulls pretty good power. This is an L7805 5-volt regulator, and then it goes right across right there. So basically, I have a 12-volt battery. I connect one pin here, and I connect to the ground rail, and this supplies a 5-volt voltage to this bus here, and there's a capacitor there to smooth out things as well if there's any ripple. That's what I have for the transmitting side of things, and then I will discuss the receiver side. Okay, I'm going to briefly go over the code for my Arduino final project, microprocessor project. We're including this DHT library. That's for the humidity sensor, the DHT11. The DHT11 has a output pin, and it outputs data serially in the form of packets. So this library is just decoding the packets, and you can get both the temperature from there's a thermistor on the DHT11, and there's a humidity sensor also on the DHT11. So that's what these libraries are here. And then next we have the pin. So we're setting the pin. So I have pin 5 of the Arduino Nano connected to the output of the humidity sensor. Next we're setting which of the DHT sensors we're using the 11. There's also a 22 out there. The 11's the model I have. Here we're just setting the input pin and the type of this parameter. Next we have software serial. That's also a library. What this library does is you can assign any digital pin to be essentially another serial pin. In my case, pin 1 and 2, I think, on the Nano are serial. But if you want to write to the Nano and you're also using those serial ports, you can run into trouble. Because in my case, I have an HC12 transceiver, so I chose to use software serial to have another set of pins. And how you write to the serial, you just say, I'll come back to it. You use the MySerial command. Instead of serial print, you do MySerial print, and that writes to the pins that you assign here. Okay, and then I have my notes, pins 2 and 3, which connect to the HC12. Next, you have your void set up. So what we're doing, we're starting the serial monitor, 9600 baud, and here we have MySerial. We're also starting that up at 9600 baud, and that's correlating to the software serial library and the pins set here. This line is basically just saying that we've started the DHT and we're testing it, so that's just a test. And here's the DHT begin, so you'll need that as well for decoding. Okay, next, the void loop. I'm reading analog read 0. That's where I have the TMP36, the analog output. That's a 0 to 5 volt signal. And here's the code I came up with from the graph in the TMP36's manual. So there might be a better way to do it, but that's how I'm doing it. And then I have the Celsius and Fahrenheit. Okay, so now we're going to assign floating variables to the DH11 humidity sensor. Notice you use the DHT dot, read humidity, read temperature, so forth. Those are from the library. That's where that comes from. So we have H for humidity, T is Celsius, and F is the temperature. That's a floating point. You'll notice here that I took the humidity and the floating point temperature, and I created those as a string. So I needed to do that. I make them a string because down here when I write to the HC12 transceiver, we need to just send a string to the myprint, so that's actually sending it to the HC12 over pins 2 and 3. Okay, let's go back. Here I make a string from the temp36 sensor, and I found that the temperature sensor here is about 6 degrees higher, or it's off from what the temperature sensor is on the DHT11. So I'm basically just reading this right now and making a string. I was printing this, I was sending this over, but now I'm using the DHT11. Okay, and then so here, this is just serial print for testing. I'll demonstrate that in a bit. And this is actually sending data over RF string is what's actually being printed into the MySerial, and that's what's going into the HC12 transceiver and being sent. So I'm going to go Tools, and Serial Monitor. There we go. Hopefully you can see that. There's the DHT. So here's the temperature from the TMP36. It says 76 degrees and 24 degrees Celsius, whereas the degrees and temperature Fahrenheit from the DHT11 is 71. Here's humidity. Okay, so I'm going to download to the Arduino Nano the program which I just demonstrated. Let's see. Oh, I guess you can't see it. So I'm going to plug it in. Let's see if I get that in the shot. And then I'm going to download to it. Let's go. Sketch upload. Okay. Okay, so it's done uploading. And then tools, let's go to the serial monitor just to make sure it's doing what we think it is. Okay. If you follow me, we'll go to the room that has the Raspberry Pi. So I have the HC12 there in the back, and then I have it wired to the UART pins on the Arduino, and there's also the fan there. So let's fire this up. While that's loading, I'll explain which pins it's going to. So there we go. Okay, let's let that load. So, successfully see if those values are coming and we're decoding them, we're going to go up here. We're going to open the Thonny Python IDE, which I have my Python code in. I'm going to hit play on that. There we go. So there are the temperature in Fahrenheit and humidity in percent values coming from the Arduino Nano. Okay, I should explain this a little bit. We're using some libraries here as well. We're using the serial library request to MariaDB. The MariaDB is a library that lets us connect to the MariaDB database. It's a SQL database. Structured Query Language is what that stands for, if I'm correct. And MariaDB is really close to my SQL. I was using SQLite, but ran into issues getting that to connect with the Perspective application. Next, we have the date time. I'm just getting I'm using this for the timestamp. This serial sub function is opening the TTY port, which is the UART0 that we talked about here. We're setting up a 9600 baud rate, which is exactly the same as what we have on the Arduino. No parity, no stop bits, and 8 bytes. So there's that. And then basically while if something is coming on the UART pins, it will read that in, and then once it's read in, it's going to decode it, and it's going to look for a comma. So that's the comma we set up in that string, the Arduino. And if the length is greater than 1, it will assign the first C0. That's the first. It'll assign that first value to T, and it'll assign the second floating point value to H. And I'm setting it in the order of temperature first, humidity second. Okay, next, the T and the H, which are temperature and humidity, those are being plopped into the MariaInsert function. And as my notes, you see, it calls MariaDB insert function. Okay, so now we get to the MariaInsert function. So everything here in this serial sub function is just reading it off the UART pins there, if that makes sense. So the MariaInsert function is doing what it says. It's inserting the T and H values into the database that I set up. So the user, there's your username, Beehive name, or that's not Beehive, that's Beehive is the password, localhost. So if you had it running on like a remote machine, you could type that IP address in there, and then the 3306 is the port, which I guess this port is pretty common for databases. Now the database name, the name, not the table, is ECW test, that's the name. And if you're asking like, hey, what's this try except about? Basically it's if this fails, it won't just stop your code, it'll print out the error and it'll keep running. So if you have something that may or may not work, but you want your other code to keep running, make sure you do the try except function. Okay. Next, so this is just logging in to your database like you would normally for a SQL database. And then next we're going to use the same try except. We're going to insert into the th readings. Now this is a table located inside of the ECW test. Table, database, table, database. Just to make those clear. We're inserting temp, humid, and Rx time. That is the name of the temperature column, humidity column, and the receive time column. We're inserting these values. See the curly brackets, curly braces, I guess it braces, and the now timestamp. And this was pretty tricky. Wasn't super familiar with Python, so that threw me for a loop till I figured this how to insert variables into a string there. So that runs it's not a query, it's basically, it pushes the values into the database, and if there's an error, it'll print that error, like, hey, one of your values is named off wrong or something. And then these values are actually committed, like set in stone, so to speak, with this con.commit. And then you want to, lastly, in this function, we close the connection to the database. So, you know, if there's no reading here, it's not tying up resources on the Pi. And then lastly, after I define both the serial sub and Maria insert, I'm only calling the serial sub function. Within the serial sub function, it's calling the Maria insert in this line here. Okay, so there's that, and I'm going to stop this video now. Okay, a couple of things I would like to show. So if we have this running, which I'm going to start running again, and then it should start getting values. There we go. It's reading in values. Every 6 seconds I have it configured to read in values. So if you're just asking like, hey, how do I know that there's actually a database running? Like what's going on there? I'm going to show you how to get to just the SQL database. So putting this little guy on a tripod. And there we go. That'll have to work. You can hit Control-Alt-T. This opens up a terminal. And then you can type in MySQL -u. That's the username. Raspberry Pi Man, and then -p, hit the return, and then type in your password to the database. Okay, I'll pull this guy off. So now we're into the Maria database. Cool, fine or dandy. I don't know if you can see that. I'll just say you can. And you can type in use the database you want to use. So that's ECW test, semicolon. It says database changed, and so it's going to take a little bit. Okay, I'll put this back up here. Now say you want to run a query. We're going to go select star, meaning all characters, from th_readings. That's the temperature humidity table I created, semicolon, and that will select everything that's in there. So as you notice, there's 2,435 rows in the set, and that took 0.045 seconds to return. And then here's today's date, which is wrong. I have the Raspberry Pi configured as a hotspot, so that's what this guy is indicating. And then there's, yeah, so it's currently configured as a hotspot, so the date is off, and I have it configured as a hotspot so I can connect to it with a mobile device, which I'll show in a moment. Okay, let's say we run this query again, and if what I said is true with this Python script, if it is actually inputting values with this MariaDB function, Maria insert function, then we should see this number grow with time. So I'm going to run it again. Now note there's 2,435. Now there's 2,446. So yes, indeed, there are values going into the table. Okay, that's the MariaDB database. Now, what about the ignition perspective? I will record that next. Maybe that's better. I think that's better. There we go. Okay, so now to get to the ignition database. Again, we're going to open up a terminal, Control-Alt-T, or you can hit this command up top. We have that open. We actually have two open. I'm going to close one. And then I have my ignition notes on how to get to it. We need to change directories to -user -local -ignition, hit return, and use the sudo command, because you need to have root access, period, /ignition, period, sh, start. Now what is that doing? That is starting the gateway. So it's actually opening up the program, the ignition program, and starting a gateway. You can now open up a web browser. I'll close some of these tabs. I only have 1 GB of RAM on this computer, so it runs really slow and it will crash if you have anything else open. This is a Raspberry Pi 3. Okay, so we're opening a web browser. Now you can type in localhost :8088. Now that's the port, so it's connected to the port number 8088. Alternatively, you can type in the IP address of the host of the prospective application, or the ignition application. So as you see, it's starting.
10 years later.
Okay, finally, after taking a few minutes, it's going to load up to the localhost page. This is your ignition gateway homepage. And there's a home tab, status tab, and configuration tab. We're going to log in. And then notice how I put the same name and password. I would recommend changing that if you're running this on anything but a demonstration. Okay, so say you want to run a project, you would come down here, view projects, you click it, and then there's a Maria test I have. I actually want to import a project, because one thing about the Raspberry Pi is that you cannot actually develop the applications. Design launcher will not run on Ignition. So just want to say that. You can run on Linux, and you could run it on your Windows, or even Macintosh, but it's not going to run on your Pi. So what I'm doing right now is I have a USB connected, and I have my project that I need to import the project. Choose File, and we're going to go to Drive, and the project, and then we're going to call it App location, import. Okay, it's been imported. Okay, I'm going to show how to connect to the Raspberry Pi. This is on another computer. We're going to need to connect to the Wi-Fi of the Pi. So we're going to wait for Raspberry Pi Wi-Fi. We're going to connect to it. Okay, so we're connected to the Raspberry Pi Wi-Fi. We're going to open up a web browser. So now you can't type in localhost because it's not running on my computer. What we have to do is type in the IP address of the Raspberry Pi, what it's connected to. So I have configured a 192.168.4.1:8088. So we'll put that in. And it's trying to load. Okay, looks like it loaded up finally. We'll go view projects. We're going to go launch the Hive monitoring project. It's loading pretty good, so we shouldn't have any issues. Green close. Alright, so those are the values that were going into the database. So let's actually take a look at the database. This database is updating every 30 seconds. That's the pull rate I have. And here's the reading ID, temp, humidity, and the RX time. This is a received timestamp. I'm still working to be able to get that to come in correctly. This has to do with formatting. So here's the trending. Looks like it's staying down here on the bottom is humidity. It's staying pretty steady at 40, and it looks like we're about right in the middle between 75 and 70 there. That's the temperature. Before, when I had the TMP36, you could really see fluctuation. There's 10 points here, and it's basically what I have is on the far right, it's reading the last SQL point that came in, and then it's pulling. So this would be like the last value -1, last value -2, all the way back to 10. So there's 10 points here as well, and it's running. The same with humidity as well. Had a lot of issues with trying to pull values from the SQL database. Security alarm page. If there's an active alarm, it will show up here. So if your temperature were to get out of a certain range that you didn't want, you could have it display an alarm and notify you. And lastly, the gateway information. So this is the time from the gateway, that is the Raspberry Pi, not your local computer. Notice the time difference between my computer and there. Tells you the system name, and here's the uptime of the Raspberry Pi. That's the gateway. It's been up for 16 minutes. At this moment in time, I put my hand on the DHT11 sensor to indicate a rise in heat. Let's go back to trending. So the humidity is going way up, and the temperature's slowly increasing as well. So what I'm going to do, I'm going to let go of the DHT11 sensor, and I'm going to see what it does. It looks like the humidity is dropping now, just from me letting go, and the temp's probably at 80 degrees. And it should start leveling out. Now if you set, so the Arduino is reading, or it's sending out data every 6 seconds. The plan was to monitor the beehive once per hour, so this trend would show a 10-hour trend for your beehive. And it looks like the humidity's dropped down to under 35 there. And we could check that. We're at 34 here, 79 degrees for the temperature.